Welcome to this explainer. You know, right now, artificial intelligence safety is going through an absolutely massive evolution. We are fundamentally moving away from just building conversational guardrails, and instead, we're engineering fully governed, multi-step intelligence systems. Honestly, think of it like moving from putting a seatbelt on a stationary car to engineering an entire high-speed traffic control grid. Today, we're unpacking a really insightful paper by Dr. Wesley Shu from the Institute of Energetic Paradigm. We are going to look at two major forces in this space, Anthropic's behavioral alignment approach and the energetic paradigm's structural control architecture.
So to really grasp this shift, we've got to look at a fundamental contrast: safe words versus safe actions. For a long time, the safety question for large language models was basically framed as a problem of answers, right? Like, would the model politely refuse a harmful request? But now we have to ask a much bigger question. What happens when a model transitions from just generating helpful answers on a screen to autonomously executing tasks out there in the real world? An aligned model might say absolutely all the right things, but still trigger a catastrophic real-world action.
Section 1.
Beyond the chatbot screen.
Section 2. Anthropic's Trustworthy AI Core, Securing the Engine.
Okay, let's dive into this. Anthropic, who is a recognized leader in AI safety, starts by securing the core engine of intelligence. They work right at the model level and expand outward. And they do this through something called constitutional AI. Instead of relying on a human to judge every single response, which, let's be real, is incredibly expensive and just doesn't scale, Anthropic literally gives the model a written set of principles. The model uses this constitution to critique and revise its own outputs during training. This completely transforms the model from something that just rigidly follows isolated rules into a trustworthy, principled participant that actually understands the balance between safety, ethics, and helpfulness.
Building right on top of that constitution, we get behavioral alignment. Anthropic builds a highly trained engine that learns these constraints directly into its response process. The model's actual disposition is shaped so it naturally, almost instinctively, selects safe responses, generalizing even in completely novel situations. The huge advantage here is steerability. Even if a user tries a completely weird or disguised prompt to jailbreak the system, a behaviorally aligned model can often reason from its principles and recognize the danger rather than just blindly matching pre-programmed rules. It's a real game changer.
But here's the thing. Anthropic's work isn't just about what the model spits out. They also tackle crucial system-level risks to cap the potential blast radius of any errors. They evaluate capabilities rigorously through intense red teaming. They enforce a responsible scaling policy, which is this brilliant governance rule tying dangerous capabilities to strict organizational obligations. And as models become autonomous agents using real-world tools, Anthropic implements strict product containment boundaries. They are doing serious, vital work across multiple layers to make sure that core engine and its immediate environment are safe.
Section 3. The System Control Gap, Macro-Level Dilemmas.
All right, imagine this scenario for a second. An aligned model is asked to update a database. It correctly understands the prompt and executes the code with zero harmful intent. It's behaving perfectly based on its training. But here's the catch. The user actually directed it to the wrong database. And because of that single, totally innocent update, an irreversible, cascading downstream automated process is triggered. The model wasn't evil. No way. It wasn't trying to do harm. The danger arose entirely from the system structure, fragmented responsibility, and a sheer lack of total operational awareness.
And this brilliantly illustrates exactly what Dr. Wesley Shu notes: safety requires converting these good intentions into an explicit architecture of controlled transition. We literally have to represent the entire process, from the initial intention all the way to the final consequence. Which brings us perfectly to the second half of this safety equation, the energetic paradigm.
Section 4. Governing the entire system, the secure track.
So this introduces the energetic paradigm, or EP for short. It's a high-level, model-independent control language that treats intelligent systems as a controlled field of states, transitions, constraints, permissions, and validation. EP doesn't just judge the language model's text response. Instead, it governs the actual movement, the transition from intention to real-world action. EP doesn't ask, hey, did the model say a safe sentence? It asks, how does a harmful outcome actually get produced through the complete chain of action? And how do we build visible structural gates to block it?
To pull this off, EP enforces a super strict separation between capability and authority. In the energetic paradigm, just knowing how to do something does not automatically grant you the permission to execute it, right? Like a model might be highly capable of identifying the exact code needed to delete a server directory. But unless it possesses the explicit state-dependent authority to do so, that action is blocked. Intelligence is completely, cleanly separated from control. EP also draws a hard line between hard constraints and soft attractions. An attraction is basically a preferred direction, like completing a task faster or saving computing costs. A hard constraint, on the other hand, is a non-negotiable boundary. Think legal limits, a data privacy wall, or a required human approval. The rule in EP is simple and it's absolute. A system cannot optimize its way out of safety. A massive efficiency gain can never ever override a hard safety boundary.
So before an AI's action gets to actually change anything in the real world, it hits these architectural validation checkpoints. Is the transition authorized? Are all hard constraints preserved? Does it increase our accumulated risk? Is the action even reversible? And crucially, what is the evidence that the target state is valid? EP doesn't just take the AI's word for it when it says email sent, it demands proof, a cryptographic hash, an audit record, or a passing test suite to validate the target state. These are the literal gates of admissibility. Now, what's really interesting about this slide is how the energetic paradigm fundamentally rethinks memory itself. Memory is no longer just a semantic text log of a really long chat conversation. It becomes control memory. Before an agent is allowed to act, it must retrieve safety procedures, active constraints, and unresolved obligations. If it's about to modify a production system, it pulls up past failed changes and permission limits first. Memory becomes a vital control function to manage risk, not just a recall tool for chatting. Section 5. A unified safety architecture. Complementary halves.
So the crucial point is that Anthropic and Epi are complementary. They are addressing related but totally distinct problems. Notice how Anthropic's model-centric safeguards slot absolutely perfectly into Epi's broader framework. Anthropic's constitution provides the normative constraints. Their capability evaluations map directly to Epi's transition power estimations. Anthropic's deployment policy defines the admissible risk envelopes, and their containment strategies bound the reachable state space. Epi simply provides the overarching grammar and structural network to connect these incredible behavioral safety tools to real-world consequences. It bridges models, tools, and humans.
When you actually combine Anthropic's behavioral alignment with EP's structural control language, the benefits are just profound. You control the actual formation of harm across multiple steps, not just the expression of it in a chat window. You prevent those scary, self-amplifying feedback loops where a model makes a mistake, trusts the mistake, and spirals completely out of control. Reversibility actually becomes a core design feature. And because EP is model agnostic, you can safely govern enterprise workflows that makes open source models, proprietary models, legacy software, and human experts all running on the exact same track.
I want to leave you with a massive question to ponder today. As AI rapidly shifts from polite conversations to autonomous real-world action, are we building the right invisible gates to govern what these systems are actually allowed to do? We have made incredible strides in aligning models to be helpful and honest, but the future of safety relies on controlling the complete intelligent system. Thanks so much for joining me on this explainer, and keep asking the big questions.